Hello, everybody. Welcome to this new live. I'm really excited about this chapter because I really like server management. Hello, Mr. Nino Hedi or Hedai or welcome, Mr. Jose Miguel Jauregui Garcia. Not delayed, dramatic entry. Well, that's at least what I can say about this. Mario Zaragoza. Yes, you've arrived early. I hope you're still there, because I think uh, that there are only two guys at YouTube. Uh-uh. And on Facebook. Okay. I've seen something that in Facebook there's not much people that get in the stream. I guess it has something to do with how it wants ads, paid ads. But well, I'm gonna sit here, and I hope you do as well. Thank you very much for being in this live. And today we're gonna be continuing the GNU Linux course that we have been having or uploading uh, since 3 weeks ago, I guess. Uh, so we're gonna be talking about a topic that I really like. I really love that topic, and that is why you should generate the SSH keys and the way you have to generate the SSH keys. I hope this is going to be a very short tutorial or video because it is not that complex to generate the SSH keys. Uh, but something that is really important uh, is that you need to know how to do that. And by the way, I remembered something, but we're gonna talk about that. Last episode, we took uh, an approach on DHCP server, and there were people that were interested in that, and I hope that uh, it was it was right. I think that it was right at the end of the day, but I hope that today it ends up more clear, because I remember that we have a DHCP Linux server configuration post that we posted on September the 8th of 2022. In 2022. So I hope you give it a try, just in case you had problems. It is in Spanish though, so maybe you would have to pass it through something like Google Translate or whatever. If you're taking this live, I guess it's because your mother tongue is English, but it doesn't really matter. The point is that you learn what you need to learn in order for this to work. Now, uh, just FYI, Mr. Jauregui, I have not taken, well, I've taken two espressos by this time, and maybe I'm gonna put another one because I really, um, I really need that one because it's been a top day today. Because we're currently implementing a firewall with one of our clients, and we've configured the appliance at first, and now we've changed that configuration. So starting from the ground up. Hi, everybody. So yeah, I hope you find this interesting. And yeah, we're gonna make we're gonna do this. What I'm about to do. Uh, in two different ways. The first one is going to be the manual one, because you need to get the logic of how it goes and how this configuration is done manually. Afterwards, we're going to do this, but we're gonna do it using the tools that the SSH service provides to us for us to configure in an easier way. And then I'm going to show you a little tool that you can use that was coded by me, I guess, 2 years ago. But uh, I've uploaded or re-uploaded it, just make a little change in the code. But if you go to the GitHub page, you'll find that there is there's something there that uh, you could look for. Now let me share. Let me share the stream with the people that are in the Telegram group, because just maybe there's not a lot of people that got the notification. So yeah, there you go. So this is a time where I put a little spam into this, because obviously, oh, whoa, this is completely cycled. Once again. There you go. It's because it freezes. But yeah, we're Ethergroup. Ethergroup is a cybersecurity and cloud firm. We provide cybersecurity services just in case that you're interested in one of our services, either pen testing, GRP planning, a forensic digital. This one has to be physical on premise, or any of our cloud services that we provide. Feel free to reach to us by one of these mails. This one is contacto@ethercloud.mx, and the other one is contacto@ethergroup.mx, and we'll be so glad to attend your needs. We also offer MSP services. That means that we manage your IT services, and with any by any chance, if you need anything from us, an implementation of virtualization, or data backup, or consultancy regarding networking, we could help you out with that. We're in transition of the web page, because we want to offer obviously the option to make it in English and Spanish, and as well. We are going to provide more information about the services that we provide. We're currently working on a platform for our cloud services, for you to reach out and get into, open an account, and that's it. It's just so you could see exactly what we provide. But in terms of things for easy understanding, you could see that there is a vCloud server, of high availability, and that's it. Hopefully, we also resell web hosting and domains. So if you need a domain and you want us to manage them, well, you could reach to us, and that's it. That's about it. Now, let's get started with the lab up to date. But thank you very much for being here. And something else regarding the last topic that we were implementing the last week. Just wait a minute, because I have a ton of windows open. Many of them I don't need. Let me close some of them. There you go. One's out, two out. This one maybe I'm not gonna need. So this one goes out again. And that's it. That's about it. There you go. There you go. I guess that's it. So if you're interested in knowing what the hell's going on, or what the hell goes on regarding a DHCP Linux server, the last video that we made, or the last Saturday live stream, we configured a DHCP server in a Debian server, which is the one that we're going to use today. And we provided access, or remote desktop access, well, actually internet access, to a virtual machine named Multipurpose Win. And right here, this one already has connection to the internet using this IP 10.40.30.5. So I'm going to get into into this VM. There you go. Hope that is a password because, I did not use this lab through the week, so it becomes a little difficult to follow along. But yeah, I think we're missing Mr. Paranoico, I guess. Okay, maybe later. Thank you very much. So yeah, right here, this virtual machine, IP-CA. I thought it was Linux. ipconfig. You see, there's a 10.40.30.5. And if I ping to google.com, you would see that I actually have internet access. And what is going on? What is going on? And we're actually going to connect to the server from this VM. And you'll see in a minute what am I talking about. This is what you see. I'm going to connect to the server. The server, by the way, is located. The server is located at. It has 2 IP addresses. This is something that we've already covered in the previous video. So if you have any doubts about what's going on, well, you can check that out without any issue. And then, but just rounding up, this virtual machine has 2 interfaces. The first one is 172.16.250.146, and the other one is 10.40.30.1. Those two virtual machines are actually, or virtual NICs, I'm sorry. Those 2 virtual NICs are going to provide internet connection to our LAN. What we configured last video was IP tables, and we actually configured, just let me show you a little bit of this. Well, this one, I'm not going to use this one. I'm going to use the other one. I'm going to use this other VM, and we're going to use tracert to google.com to see what's going on. So we're in the 10.40.30 network segment or subnet, and as you can see, we're actually getting out to the internet or reaching out the internet through the 172.16.251. That one. These are all virtual networks. There are, before we go to the internet, so we're providing internet access through these network cards. So I hope that it is understood what is going on, because what I'm going to do is I'm going to SSH into the server, yeah, because the server has a user named Ethercloud, I guess, and it has the 10.50.40, I guess. Let me check out, because I tend to forget this type of things. Config, there you go. So it has the, just let me go with the SSH with the 10.40.30.5. There you go. And this is going to try and connect with my user, Ethercloud. There you go. And it's going to ask for a password. Refused connection. Goodbye, network you thing. Let me go to the Tartar server, because I don't think. I guess the user is Ethergroup. There you go. I remembered. So it's Ethercloud. It is indeed Ethercloud. So that one. But that is not the one. The one is the one I want to connect. And there you go. We have access to the server. Now, there is something you need to know about what we are going to create or do. At this point, you can do this in with no problem that much in Windows. But let me see what goes on with the other VM that I have, because This Debian client has one NIC that is connected to the one network or the wide area network interface of the server. That means he can reach out from the one interface. And the LAN network is reached to the server by this client. This is the only client we have. There you go. There you go. So yeah, that is the whole thing. Now, let me explain to you what we're going to do. We're going to copy the SSH keys. And for that, I'm going to SSH keys, Wikipedia once again, because there's where we can get that information. I'm actually, it's really, it's not that it's really hot, but if I change the temperature of the room, it's going to get too cold for my will. So, what is Secure Shell, which is a protocol that we're going to use? Secure Shell is a protocol. Oh, the internet we promised. I'm sorry. By the way, if you have never helped Wikipedia, this is the day that you could make a change. So yeah, go ahead and help Wikipedia a lot. Make a donation, 40 Mexican pesos, which is like $2 or $3. Go ahead and do it. Maybe $2, $2 and maybe that. So yeah, the Secure Shell protocol is a cryptographic network protocol for operating system network services securely over the network. That means Secure Shell helps us out when you're trying to connect in a secure way. It is, maybe a lot of people do not know this, but it is a VPN. It is actually a VPN, but it works as a VPN when you configure it as a VPN. It does not come out of the box with that enforcement using the private and the public key. And I'm going to explain to you something that is really interesting about how it goes on and how it happens. Now, let me open this in my machine. I'm going to open up a going to open a file in Draw. Go ahead. There you go. So right here, just to help you out with this and explain to you what goes on with the generation of SSH keys. And that is important because when you are configuring a virtual machine or an SSH server, you need to know that you have the correct perf keys in order to access that. And you have a public key and you have a private key. I'm going to make a little change to this machine, to this virtual machine, this one. I'm going to close it up. Yeah, I'm going to close this machine. And I'm going to add another NIC to that virtual machine. The Debian client, I'm going to turn it off. Well, I think I can add another NIC. Yeah. But this is going to be into the hack lab, because that's the network where this other VMs are attached to. So I'm going to get in there and I'm going to, hopefully I can still connect to the to that virtual machine. Let me see. Just wait a minute. Hopefully I can. It seems like I can. There you go. So I'm going to connect to this virtual machine and we're going to make that configuration first. How would we do it in Linux? And then we're going to change that configuration on how it is possible to do it using Windows. So right here I have my Debian client. I can obviously access or ping the, let me see, just check out set schema s. This is just to change the language. I'm actually connecting to this virtual machine using you see, I have a 10.40.30.6 VM. That means I can ping to 10.40.30.1. I can ping to that virtual machine, which is our server. So that means that I can SSH into the server. So ether cloud at 10. We're gonna make several changes to this. This is like the traditional way of doing this. I'm going to change that into a more, actually, more secure, and is actually easier to connect. That is by using names, and that is using a something called a config file in SSH. Now, for that, obviously, I need to create my pair of keys, but I'm going to explain to you first what is that, what the hell does that mean, and then we're going to make that into a practice. Now, I'm going to go here, the one, and you can see I can connect to that using the SSH password. But this is not correct. This is something you have to know. And I remember that the last stream that we did, there was someone that was not, it was not like, it was not, uh, how can I say this? He didn't like that we connected to the server using the password. And that is correct. But, you know, this is a Linux server course. That means that you have to take it step by step. So now it is the moment when we're going to harden that service. That what harden means is that we are going to add security to the service. Now, this is going to plain text password that is going through the network, reach out the server, but that is not the correct way to do this. Now, and then what is the right way to do that? Now, you see this is a Debian machine, this one that you're seeing, and it has two NICs connected. The first one is the one that gives out the internet, and the other one is connected to the network of the Linux server. Now we're going to configure, but let me explain to you first what goes on with this. Just let me horizontal. There you go. And now we're ready to go. Now you have to know that SSH key pairing is not new. You know, it's not new. You have to know that the definition uses public key cryptography to authenticate to the remote host. Okay, that means that you create your own identity with a very sophisticated algorithm that will provide security layers on top of your communication. That means imagine just a tunnel, and through that tunnel goes all your information. But SSH, what it does is it encapsulates all that traffic with cryptography. And that is what makes it secure. The only downside of that, in my opinion, is that you need to share at least once the public key. But you never share your private key. You always share your public key. You know, for example, there's an algorithm named Diffie-Hellman, and Diffie-Hellman had this downside that was you needed to share a secret key through the network, maybe, unless you had like physical access to both ends of the communication. And that is a problem because it ends up not being that well. It ends up being or having problems because you already shared what needs to be secret. I don't know if you're getting that, but you're sharing what needs to be secret. And after many things that were done to change that, because that was what happened, it ended up being just as important or as good as, let me show you this. Let me do something. So yeah. Uh, it ended up being a problem, but SSH cryptography changes this. Now, how it works at the end of the day, imagine we have a user. Let me insert a text because I don't remember how to do this, but insert text. Text. There you go. I'm gonna put something right here. I'm gonna actually be cloning this. But right here we have Alice. You know the Alice and Bob. We have Alice, and on the other side we have Bob. Both of them want to have a good communication. They want to share. They want to share information. Okay. The problem with that is it is not secure. At the end of the day, it is not secure to share information through a tunnel in between. For example, let me show you this. So this is the communication that they want to have. This is a network, and this is a tunnel of information, okay? Imagine this one is a PC1 or PC2, you know. Maybe this is going to be the client or the admin. In our case, it would be our admin. And over here, we will have a managed server. Now, this one has an IP of 10 dot, which IP it has? IP minus C8. This one has 10.40.30.6. Now, 10.40.30.1.6 slash, this is the CDR. And this one has 10.40.30. This is the server. This is our Linux server. Now, this is a tunnel. We need to create an SSH tunnel. There are many tunnels that we could create. There are red tunnels. There are IPsec tunnels. There are many, many, many tunnels that we could use, but in this case, to manage this service, we need to connect securely through there. Now, we could use a password communication, but if there was a third person, I don't know, I'm gonna call it Charlie, for example, which I don't mean by that Charlie, man in the mill. Okay, this one's gonna be Charlie. Now, Charlie is right here listening to stuff. And if you share a password through this, if you share a password through this, maybe Charlie can catch that information. Maybe he could catch that information. And it would be so bad for everyone because we wouldn't be able to know what Charlie wants to do with that information. So you share this password, you get access, but maybe that password could be logged through the connection. But that is not the reality. The reality is that at the end of the day, these two virtual or these two users are in this virtual machine or in this connection need to have level up security, that is pair of keys, which we know as SSH keys. Now, how can we create that in order to Charlie not to be able to read what goes on in the communication process? We need to create a pair of keys. Now, how are they created? There is an algorithm and there is a size of that algorithm. And according to that, it will be more or less complicated for him to find out what goes on. And I'm going to show you what I mean by this. Imagine that we have Alice and Bob again. And this is our communication. Now, let me just duplicate this one. Just right click, duplicate that page. There you go. Now, we need to do this in a secure scenario. We need to get Charlie out of the way. For that, we're going to use a perf keys. This is using password. I'm just going to leave it like that. Password. There you go. And this one, we need to create a pair of keys. And how are they created? Well, our client, in this case Alice, which is the admin, needs to create an algorithm. I don't know if you've heard. I think this is going to be a little bit complicated if you have not read or anything about elliptic curves. Cryptography, SSH. Let me see. This is really interesting to see how it goes on. I'm going to open up this Tenable page, which are the ones that created Nessus. Look at this. Cryptography is finding and patching vulnerabilities. Okay, yeah. But look at this. This is like a very high-level example of what goes on. It's not that low level, but you would get what goes on. Imagine this. Imagine that for creating this pair of keys, we need to use a prime number, but a very big prime number. And we could also salt that. What means salt? It means when you have food, for example, the food is not going to taste the same if you put salt onto it or not. Whether you put it or not, it is going to make a change. That happens the same thing with passwords. If you salt a password, that means that you're going to put more information into the password generating process for it to correctly create a password, a secure password, or a hash. That depends on the algorithm that you're using. Now, in the case of the keys, imagine the result of the key that Alice generates plus the key that Bob generates. Alice key and Bob key is going to be equal to A and B key. A key, B key. As a result, this is a very, 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 very simple way to show you what goes on. For example, if we know or the algorithm knows that the result is going to be 3, the pair of keys are going to be like this. For example, the Alice key needs to have maybe the algorithm is what goes on here. In this case, it's just the plus sign. But right here, we have the maybe it could be times something. For example, let's take a look at the algorithm of the RSA algorithm. RSA algorithm. Let me see. Wikipedia. Look, to create the RSA, this is a crypto system. Well, let me see if we could get the algorithm. For example, there's the algorithm and what it does. This is, this is mathematical. But there's a formula that it follows to create the keys. And it is complicated to break because it uses a large pair of numbers. This is the simplest way. The way I'm trying to explain this to you is the simplest way. Because we're not going to end into these extended Euclidean algorithm or whatever. No, we're just going to, this is just for you to understand why this is secure. Look, the algorithm, for example, in this case is going to be plus. That's all the algorithm. A key plus B key equals A B key. Or maybe we could change that too, because that would be multiplying to C key, CK. AK versus BK, I mean plus BK equals CK. Now, what is what we need? We need, if we know that the pair of keys expected, this is just a number of one digit, is 13, I mean it's 3, we need two numbers that that are once added add up to 3. It could be 0 plus 3, or it could be 1 plus 2, or it could be the vice versa version of this, 2 plus 1, or it could be 3 plus 0, and so on and so on. Now, brute forcing this key would be very easy because the algorithm is just applying a sum, an addition. That is everything is going on. But what happens when we apply an algorithm such as RSA? It is much more complicated to find out what those two numbers are. And that is why we use elliptic curves. That is a mathematical approach to ensure that you find a number, a prime number, big enough for the computer to process, but also big enough for it to be secure. Imagine that we had SSH keys that were this simple. It would be very easy to crack them. And this is just the formula of a dictionary. But how the hell do you crack a password or a SSH key? Which number is very, very, very large. Now, let me show you this. I took a course, a cryptography course, a long time ago with one of it is cybersecurity from from an approach, from a cybersecurity approach. And once I took another course at the MIT Open Courseware of cybersecurity. That is why I have, like a deep understanding of this type of things, because I took those classes and it was very interesting to see how it goes, low level. It is just not to do things by the will or just because you want to do them. You need to know why. Look at this. Look at this. The elliptic curve, in a very simple way, is a smooth projective algebraic curve, okay, which is this, that makes you do a lot of things. But cybersecurity experts or algorithm cryptography experts have taken that algorithm and they generated the way for it to produce a secure key. Now let me open that page once again. I'm just going to copy this because that's all I need. And now look at this. This is, oh, we missed. What is this algorithm? Oh, it's because it is here. It is actually here. So, yeah. There you go. So now we have this pair of keys, but how can we get that number? A number that is so interesting that we could just generate it and that's it. I'm going to let me insert a form. There we go. So imagine, let me see if I can find a elliptic curve. Well, I take that circle and then we are going to, yeah, there you go. So imagine this. In order to find, this is a very simple way of explaining what is going on, but bear with me and you'll understand. You'll understand. Bear with me. Just bear with me. Twitch. The more ingredients and the more large prime, and some trying to copy it will need more combinations to copycat it. That is the right thing, Mr. Takinux, and that is the way this is secured. But yeah, let me show you this. Uh, when you are finding a number for your SSH key, let me see. You find, for example, a combination that leads to that point of the elliptic curve, and there is another one at another point, and those 2 points that I'm living right here are. Let me see if I can. Get it. Oh, there you go. Maybe this one. Okay. Maybe this one. Again. This was thinner. So yeah. And let me change the color of this. Well, from this shape. White. There you go. So a little circle. Maybe this one, noticeable. And that's it, I guess. So I'm going to leave just a little point because we need to connect that to something. But you'll know. Let me see. Where is this? Come on, man. So this intersection that we're seeing right here between the elliptic curve, in this case, this is well, it's an elliptic form. Let me see if I can. There you go. That is perfect. That is perfect. But maybe the color I need to change. There you go. So the color is going to be green, maybe. There you go. I don't know why I associate cryptography with green. I don't know why. But look, this is an intersection and this one is another intersection. And those 2 numbers, that imagine it starts from zero all the way to whatever this elliptic curve goes. Or whatever the algorithm leaves it to go. And imagine adding up a salt to this, what I explained earlier. So let me just put a little dot, just a little dot. I'm going to copy it, paste it. I'm going to grab it. Oh my God. Was screwed up. Screwed up. Going to come over here. Let's see. There's our intersection there. There you go. Oh my God. Come on, man. Come on, man. I think I needed to do this. So yeah. Let's say this is our intersection. That's it. I'm just gonna leave it right there. Yeah, I'm just gonna leave it right there. So, just as we thought, it is very complicated to find out which numbers are those 2. Let me change the color just for the purpose of changing it. This. And all those 2 numbers or those 2 intersections are going to be used to find out what the hell are going to be the values of AK and BK. Obviously, they're going to be applied to an algorithm more complex than just adding, and that is going to make it very complicated. And imagine that after, this is the basic algorithm, but imagine that if you add a password to it, because when you generate a pair of keys, you could add a password. Then this is going to be like something like AK plus BK. And another algorithm, in this case, I could do it like multiply. I could do, I don't know, divide or a modulus of something of password equals CK. This is the salt. Let me see. Let me just. The password is in reality a salt at this point. Is a salt or the algorithm to be more complicated, and that is it. This is what are we going to get. And if you're more interested in that, we could start a series of cryptography. I really love the topic. And I created a long time ago. This was actually for Mr. Jauregui. This was actually my first what I talked about first at Grupo Usuario de Linux de la Laguna. It is a Linux users group that is here in Torreon. And I talked about it with all this. If you see creds, PastScript and PastScript v0, this is an algorithm that I created 9 years ago. Just saying. This is coded in C. I coded it in C. And it was an algorithm that could take a text, a file containing text. It would pass through the algorithm, and it needs, there's actually a video where I explain this, but this CR.H is the library that I used. And this is, you see, you use a modulus. It changed all the values, and depending on what you add at the Fibonacci algorithm with the key and a modulus, or modulus, or module, I think. I don't remember how that's in English, but if you add this could be any values, depending on the on what are you going to use them for, but they could be different. And you compile this, and that is your own way of going in and out of your encoded password. Maybe I will show something about this along with what I'm trying to explain. You know, I know this is a complicated topic. I mean, this is not so basic, but you need to understand what I really like when people understand what is going on and not just using the tools because they're there. You need to understand what goes on. Now, let me continue with this. Edwin Gonzalez, Jaime Torres Pelazo, happy hacking, my friend, and welcome to this live. You know, you're really welcome. I really like when you get in the live stream. But yeah, let me drink some water because it was a mouthful. If you want me to show you what goes on with that algorithm, I show you with no problem. Just bear with me because we're barely starting with this. But yeah, this thing that goes on with the algorithm is the way that SSH is secure with. And now this ends up with this A and B K, and this CK is in reality a public key and a private key. And this is what you share, the public key. And that is why this is secure, because even though we could know what the hell is this, in an algorithm like RSA, for example, this one that calculates and does a lot of things, step 1, 2, and 3, or 4. Also, something very important about cryptography is that all the algorithms that you're going to put into the table need to be reversible. What does that mean? That means that what you put inside needs to get out. You cannot modify with the algorithm that you're using. You cannot modify what goes on into in the output of that algorithm. If I have this, imagine this is an algorithm. If I input that some information into this algorithm, what I expect here is nonsense. But once I pass it again through that algorithm, I need to get all the sense possible. Every bit of information needs to be correct. That is the way that cryptography must work. And I'm going to show you what I mean by this, but bear with me, bear with me. That is how SSH key works. At the end, what we want is a public and a private key, and that is personal. Now, how are we going to do this? Emir, I already take a look. I've already know what goes on, but how the hell am I going to connect to that? How the hell am I going to use this? Well, just let me show you what goes on. Oh, let me. There you go. This is a normal PC, and we're going to, this virtual machine is actually inside the network of our LAN. Now, there you go. So, I can still ping the what? Yeah. I'm going to create right here in my machine, let me open up. This one is a server. And if I, well, just, there you go. So this one, this is the server. This is this IP. And now, let me show you something. If I go with su minus if I consult the server, you can see that it is actually running on port 22. We're going to make some changes. Now, from the client, what we're going to do, I'm going to list something because this one has to exist. This is an SSH key. How can we generate our pair of keys? Well, it is very easy. If we go to SSH key generation, SSH keygen, this is a command. Whoa. See, help. Come on. Man SSH keygen. So this is a command to create our passwords, to create a lot of things, but among all those options, we're going to create a pair of keys. Just like this algorithm I showed you. We're going to create a pair of public and private keys. This is going to be shared, okay? This is going to be shared. This, at the end of the day, is going to make a secure connection between this, but the public and private key is generated just in one side of the communication. And the key is shared, and all this process that I'm showing you right here is just to decrypt. Okay. Now, let me show you this. Let me show you how can we generate that. SSH keygen, okay, with that. We can use the -R option, which is, I'm sorry, -T, which is the type of algorithm. We're going to create an RSA key. And the bits are going to be the longitude or the size of those keys. I'm going to put I don't remember if that is the value. I think it's that one. Yeah. So 4096. So this is going to create a pair of keys like this. Like this. So I'm going to do this. And it's going to ask me for a name. If you can see in this example, it is generating the .ssh key just here in my home directory. And it's creating a folder named .ssh/idrsa. And if I just click enter, it's going to generate a pair of keys, just like that. It says that it already exists. Okay, I'm just going to cancel it because I think that those keys are needed for something else. Then I'm going to change the name. The name is going to be Tartar. Tartar. And look, this is a passphrase. This is what I showed you right here, that it is a password. It's all. Passphrase. I'm going to click enter for no. No. And I have an RSA. Now, this is ASCII art. And this is generated because when you're using this algorithm is generating the elliptic curve. And in order to do that, it needs to generate random characters or random positions in an image for it to find those two spots I showed you. That is why when you use putty, which if there's time, we're going to check it out, how it is set up in um, how it is set up in Windows. When you use putty, it asks you, when you're generating your pair of keys, it asks you to move the mouse or the cursor around a screen because it is going to try to create a random image, and from that random image, find two prime numbers in general, two prime numbers to calculate your pair of keys. That is why you need to do that. That is the reason why. That is the reason why. But yeah, in general, that's it. Using RSA is good choice. Yeah, it is a very good choice, Mr. Nino. But yeah, that is what goes on. And now we have a pair of keys. Now, what the hell goes on after this? Look, let me show you something. We have tartar and tartar.pub. I'm going to move those keys. I'm actually going to yeah, I'm going to do this manually at first, okay? And that is that is not that that is the right way to do that, but you need to know in case you need to add the SSH key to a server, and you maybe just have the SSH client, which is weird. It rarely happens, but let me show you this. In the server, we're going to use the user Ethercloud for this. I'm at the home of the user. Okay. Remember, SSH keys are normally used with users that do not have privileged access. Or you add another two-factor authentication, for example, Google Authenticator, the module, you add it. Or you use a passphrase or whatever else, because if you leave it like that, directly to root, it's passwordless. Passwordless. That is not a good thing to do. So I'm going to create something with ls minus alt. You could see the permissions, the owner, and the information or the metadata, general metadata about the files or the folders that are in in there. What I'm going to do now is I'm going to create a folder named .ssh, just like we have over here. Just like I'm going to move that. Well, no, I'm going to create SSH dot. It's good enough to cause trouble. Attacker using AI to decrypt it. Yeah, I know. If you're just living it like that, yeah. But yeah, it is good enough to cause trouble. Because most of the people do not tend to secure their servers. In the process of what we're going to be doing right here, this is a basic course, but you need to understand the deeps, what lies behind all everything that is over there, out there. Many people do not know that this type of things happen. What Nino is saying is very, very important. So don't leave it like that. You need to do this. So I'm going to create a folder called Tartar. And I'm going to move all the tartar files. If you put an asterisk at the end, it's going to move everything that has tartar on it into SSH tartar. And now if I go to SSH tartar with the cd command, you could see that now my keys are here. Now I'm going to treat my keys right here. With the cat command, you could see your keys. The pub, which is the one that we're going to use. If you can see, the Unix type connection when SSH or the SSH Open SSH format is this one. PuTTY uses another format, but this one is very easy to understand. You have the algorithm. You have what algorithm is the SSH server going to use. Afterwards, there's everything that we made public in the cryptographic key generation, and then the user and from where it is going to connect. This one can be changed no matter what, because this is going to go to a folder in the server and actually in a specific file named authorized keys. And that is the way it identifies that this key is valid for this user. And from the user side, it is going to create a known host key. No host, I guess. We're going to check that out afterwards. But that key is going to be saved as a valid key. If this file changes in your machine as an admin or in the server, it is going to throw an error. It's going to say somebody's making something nasty. Either the IP changes, either someone is trying to fool this, but maybe the key could be correct. But if it's being accessed from another server, it is going to try and is going to explode. It's going to explode. It's not going to leave you do that as easy as that. Maybe you would need to clean that registry. But well, now, what we're going to do now? We're going to pass this to our server. Now, we're going to go here. Like I told you, I created a folder. Now, it was not here. I created with mkdir, and the SSH folder is there. Now, I need to change the permissions of that folder. And to do that, just let me do something very quick. Help. There you go. New. See, okay. I'm going to change the mod to 0700 for the SSH key. Why? Because the ownership, if you go to man chmod, this is like the first approach that we're gonna have to Linux permissions. But you could see here in the manual, it is explained what happens to the values that we add. We have read, write, and execute permission for the owner, the group, and all others. Okay, so let me see if I can. Let me see if I can find some information about that for you to understand what goes on and why we are creating the folder like that. So Linux permissions system. This is an octal system, actually. Why? Because, let me see if I can find something like that. There you go. We have read, write, and execute commands. This is by Linode. By Linode, I guess. Let me see if I can find that image. Okay, right here. Look at this. We have an octal value of 7, 6, 5, 4, 3, 2, and 1. And everything is treated like an operation. Yeah. Read, write, and execute means you have everything. And you can see right here in the documentation that I just showed you in the man, you could see that these values are 4, 2, and 1. Or, for example, 4 is read, 2 is write, and 1 is execute. That is why normally we do chmod plus X. What this does in reality is assign 111, execute, execute, execute to all the users. So it is better to do 0, 1, 1, 0, which is just like this. 0, execute. Maybe this is just complicated, but which is like this. If I want to give access to execute a binary, I would only add 1. Read, write, execute. 1. If I wanted to do 2, for example, write and execute, only write this one. If I wanted to do write and execute, it would be 3, because 2 and 1 adds up to 3. If it was 4, just for reading, it would be the 4. And no write or execute would be possible. 5 would be read and execute. Would be 6 would be read or write. And 7 would be everything. And that applies to users, groups, and others. Look at this. Maybe I'm going to leave you this link. Let me share this one to you. With you, I mean, there you go. For Twitch again, there you go. And Mr. Paranoico Merola has arrived. This time from Facebook. Hi guys. Sudo sudo map Ethergroup minus T4. No, please don't. No, please no. But yeah, I don't know. It's just a pleasure to have you here, Mr. Paranoico. Big hug for you, my friend. But yeah, let's continue because I think that this is going to be for 2 episodes. It's taking too much time. But yeah, look at this. Let's continue. Let's create the folders. Now, this folder was created with the 077. That means that only the owner has every right on this folder, which means Ethercloud, which is the user, has everything. You see how this is changed? This was like very open with read, write, and execute for the groups, for the owner, read and execute for the groups, and read and execute for others. Now we've changed that to only read, write, and execute for the owner, and no one else can read this. Now, I'm going to access that SSH folder. Remember that we are here. And right here, I'm going to create a file. That file is going to be named authorized keys. Okay? And I'm going to do it with Vim. Vim authorized keys. And that is it. What am I going to do with this? I'm going to go to the client and copy exactly everything from this in my public key, not the private. Please, the private is for you. You could share this one, but not the private key. So I'm going to go here and I'm going to paste it. Exactly as it is, because it's open SSH folder format. I mean, this is single line. This is a single line. If I go to the beginning of the line, this is a single line. Now I'm going to escape, colon, write and quit. I'm going to read that file, and that is it. But we need to change the permissions of this file. We need to leave it in 600. Because we only need that the owner reads and executes that, but not writing. Not writing, I guess. Yeah. Now let me see those permissions. Oh, read and write. Just read and write. Yeah, not execute. And that is it. Now, what is going to happen with this? It is everything done? Yes. Now we can connect directly to that. Cheap viewers on Streambo. We have spam on Twitch. That is so good. Okay. Yeah. Now, we're going to try and connect from our client using our public key. How can we do this? Using our private key, I'm sorry, because I've told you that you need a public and a private. So the private is in our client, which is the tartar, and the public is the tartar.pub, which already lives in the server. Now, with SSH command, using the -t, no, I mean the -I, we're going to select our private key, and the user and the IP of the server, 40.30.1. And look at what happens. Now we are connected to the server, but it didn't ask for a password. The question is why? Because we're using cryptography. The key is already there in the server. Is this one. This is the key. It is already loaded in the server. Now the server knows that this is a valid access. Now, you may ask, but you have to do this manually? No, SSH is very, very good with this. And if I go with, let me generate another pair of keys, but I'm going to create this as Ethercloud access and mkdir Ethercloud access 2. I'm going to enter to Ethercloud access 2. And right here, I'm going to create SSH keygen. Right here, SSH -T RSA -B 496. There you go. And I'm going to create a pair of keys named, I don't know, tartar2, for example. No passphrase. There you go. Now I have a tartar2.pub. I can paste this key directly to the server with a tool that SSH provides. That is SSH copy ID. I think is the same with -I tartar.pub. Where am I going to paste this? I'm going to paste it to Ethercloud at 10.40.30.1. And it's going to ask for a password because it needs to access the server and create all the folders, everything that we need on the server, but this is going to do it automatically. Now, what is going to happen? Look at this. I'm going to read the authorized file. You can see that there's only one key. There's only one key. But when I add this one, put the password, it says, good. Now you can access this machine using SSH and check to make sure that it only keys you want here added. Let me see, because I don't know if this took my keys, the ID RSA. I don't remember if that is the correct, the -A option. -I option, I mean. But let me see. Now, if I go to SSH -etar2 at Ethercloud at 10.40.30.1. Oh yeah, there you go. Yeah, it was correctly added. Now, let me read the tartar.pub. Look at this. This is another key. But if I read it in the server, what happened to this authorized key? It added another key, another one. And that is different, you see? By the end of the lines, you see it is completely different. 2 different keys. And I would do this with every user I have. But there's something else that you need to do with the service, you need to disallow password connection. How can we do that, Emer? Well, we're going to go to su minus, which is going to take us to the home of the user. We're going to access that, and the file that we need to move to a folder in edit to config SSH, and right here we're going to edit this file named sshd-config. Beam sshd-config, and we're going to make some changes. Well, first of all, what you need to do is cp, which is going to copy the sshd-config to sshd-config.back. Why? Because you need to make a backup. Maybe you would like to take this to another place, but this is just a backup. Okay? Make it, because you could make mistakes. And if you need to reverse something, you need to make a backup. Now, let me go to beam sshd-config port. We're going to leave it in 22. We could change it though to another one. Address family, any. The listen address, we could set up a specific IP for the SSH, but I'm going to leave it. This means from anywhere. Any network card I have is going to listen. Now, we're going to go over here. The log level, we need info so it registers. There are different log levels in SSH depending on what you need to recover or collect in terms of information, but right here is going to be info, just info. And login rest time. Now, we're going to change that because we're not going to use password, so we don't need to wait a lot for the user to set up the password, type the password. No. So we could do it just like 5 seconds or less, just for the key to decrypt. This key that we added is going to decrypt. Now, permit root login. I'm going to change that to no, because we don't want people connecting with the root account to our server. And now, strict mode, yes. Max auth tries, we're going to leave it to 3. And the max sessions, I'm going to leave it to 3 as well. Why? Because maybe you opened many connections on the server, but you could use something like screen or whatever to multiplex those connections. That's up to you. Public key authentication, I'm going to put yes, because you need a public key to access that. And I'm going to uncomment this one. Ignore user no hosts. No, wait. The remote host. This one. Ignoring our host. I'm going to put no, because we need that it allows the connection from other places. Now, authorized key files. I'm going to leave this because it is going to look for this authorized keys file. Maybe I don't need this other one, which is the keys too. But if you have another file, go ahead. You could put another file. I'm just going to leave one because that's what I need. It is going to look in the users folder for that key, and then it's going to take it back. And that's it, I guess. Use spam, yes. X forwarding, I'm going to leave it in no, because it does not have any program or graphic interface. The server is just console, so I don't need the X forwarding. And that's it. There you go. And yeah. Now, what I'm going to do is save this file and do a restart of the service. Systemctl restart SSHD. Now, what happens if I go from my client, from the user's client, and I go without the key? It is going to ask for a password. But even if I put the correct password, it's going to say connection closed by port 22. Why? Because it is not allowed. What I need to do is ask or pass a valid key, in this case, the Tartar2 private key, and now it is going to let me access the server securely. Either I use this one or the other key that we created, but that is the way it is created. It is done. Now, we created these two folders. Yeah. That is the way. So, in general, that is the way that we create our SSH keys. In Windows, we could create something like that. Let me see. Let me exit this one. Using something called PuTTY. Using something called PuTTY. Wait a minute. Just wait a minute. Okay. So, yeah. To do this, we're going to use something called PuTTY. PuTTY is a tool used to generate our keys, our SSH keys. I'm going to do it with the MSI installer. Yeah, let's download it. I'm going to install this. Next, next, next. There you go. Next. And yeah, let's open up the read file, but look at that. And now we have PuTTY. Well, let me show you something because PuTTY, I'm going to add it to the toolbar as well as PuTTYGen. Because this one is going to let me connect to the server, and this other one is going to let me generate my keys. Now, let me illustrate better what I explained to you in this diagram. To generate my pair of keys, my private pair of keys, I'm going to generate right here. And look at this. Please generate some randomness by moving the mouse over the blank area. This is going to create the prime number that we need. You see our elliptic curve. That is it. And now it's created. Now look, it says public key for pasting into SSH authorized key file. This is the same format that it provided. Now I'm going to take this one. Oh, but I need to send it to the server. That is going to be a problem. But yeah. I'm going to save this, save the public key into desktop, and the private key as well. It is asking me, oh, and it is actually created with a 248, which is very small. You know, let me just change that because 4096, there you go. I'm going to generate it again. It's going to take much more time, but I need to move the mouse. You know, it's not, I need to move and create that. There you go. Now we're going to save the public key. Again, tartar. You would normally name that as your user. Yes. Tar. I guess I think it has to be laptop, and this one just tartar. There you go. So this is the public key. We could open that with a notepad, for example. This is our key. If we needed to know, for example, we open up the key generator, and we could load a key. We could load this one, for example. This is a public key for that one. Now, this would be what we need to copy from this server. Now, I'm going to change something in the server so I could copy this other key. I forgot. There you go. So I'm going to go to the server. I'm going to go to the server and Ether Cloud Access SSH -E. No, SSH -E. Oh my God. SSH-E. tartar 2 at ethercloud.10.40.30.1. There you go. Now right here, I'm going to add that authorized key, but better, I'm going to do it directly from our Windows server, our Windows client, I mean. I'm going to go to the SSH file. cd etc ssh right here, vim .sshd config, and I'm going to copy that sshd config into sshd config dot keys conf keys dot back, so we know that this is the one that has the keys, the correct keys. Now we had a backup of the default configuration. The .back file, we're gonna copy into the current file, and we're gonna restart the SSH command or server, and now I can connect from the Windows using the password. Now I'm going to go SSH at EtherCloud. With EtherCloud. Now I can see the server. I'm going to beam the SSH authorized keys, and I'm going to add another key, which is this one. I'm going to copy that. Let me see. Let's see if it leaves me. Copy this one. Copy and paste that one. Visual block. The hell, man. Okay. And with this, we're gonna end up today's video, because that's it. My God, it's not letting me. I'm gonna do it with PowerShell, because otherwise it's not gonna happen. PowerShell. SSH, Ether Cloud at 10.40.30.1, and then Beam SSH authorized keys, and right here, I need to be able to paste it. Let me see. Copy, paste it. What the hell? Nano dot SSH authorized keys. Okay, there you go. But Nano was the thing. There you go. Now I can cat the .ssh authorized keys. Now I have another key. I'm going to change the configuration of the server again. Let's see, SSH, and I'm going to CP the SSHD config, the config keys to the SSHD config, and restart the service. Now we have this, which is the configuration file that we needed. Yeah, with the changes we made. There you go. Now, what I'm gonna do now with this, I'm gonna exit, and these keys I can load them because this is just a key generator. But if I go with the PuTTY client, there's an option with the SSH auth credentials. It asks for the keys. Now let me go with browser, and I'm going to look for those keys which are in the desktop tartar. There you go. And the private key, or it was what? Private key for file certificate with the private key. That is it. Now I'm going to go back to session. I'm going to set up the IP address 10.40.30.1 on port 22. And SSH. And this is going to call Ether Cloud. And we're going to save it. It needs to be saved. Otherwise, you will need to put this one again and again and again. Now, let me go here. Click load. Click open. Yes, I accept that there is a key. Login as Ether. Let me see. Ether Cloud. And that is it. I just put the user. But yeah, now I can connect with that because the key is already there. Now we learned how to connect from Windows. We learned how to connect from a Linux client. And we're ready to roll and continue with the course of Linux servers. Just like that. I think that everybody already left. But that is okay because we already finished. So thank you very much for being in this live. And you know that this video is going to be there for everybody to consult afterwards. Remember that we're Ethergroup. If you need anything regarding cybersecurity, MSP services, or Ether or cloud services, you can contact us. We'll be so proud and be so happy to help you out with this. Now, Thanks to everybody that connected to this live. Let me just give a little shout out to the people that connected to the live stream of today. Thank you, Nino. Thank you, Edwin. Thank you, Jose Miguel, Jauregui, Taquinux. Thank you, Mario Zaragoza. And thanks to everybody that watches all our live streams. Through the week, we're going to have other live streams. And I hope that you have a perfect day. Drink coffee because that's needed every single time. You need to drink coffee. Not that much because then you're going to lose it up. But yeah, thank you everybody for being here. And we'll see each other at Ragnarok. Goodbye. Goodbye, goodbye, goodbye. Goodbye.